This video has started. Volume is max. So yeah, hello everyone. Before going to another DP problems, today I'm going to discuss the DP frameworks, which are basically each and every DP problem can be solved using one of these five DP frameworks. And today I'm going to discuss all these five DP frameworks. So without wasting much time, let's get started. So the first DP framework is take non-take form, which is form one. So let's see in which type of problems we can use this type of a DP form. So basically, wherever there is mentioned in a problem that, or we can retrieve that at each DP state we have to make decisions of something like whether to take this level or not take. In this type of situation, we generally use first form of DP. It looks something like this, having n states, and currently if I am at this state and I have to make some decision on this state whether to consider this state or not, and on the basis of that I can evaluate the final sub problem. How? Let's say I have formulated the DP state like this: DP of level comma these x1 and x2 are some variables which are storing result, best result I can get in this interval array of level up till array of last index, right? Such that these x1 x2 goes in are something that is already happened in this interval 0 to level minus 1. So that's how we generally formulate our DP state in form 1. This will become more clear when we will be coding some problems in this form. So that's how it looks, that's how the form 1 looks like. So mostly this type of DP state is used in subsequence problems. Why in subsequence problem? Because in subsequence problem we are having a string or an array and we have to uh, make decision on current index whether to include this element on a subsequence inside subsequence or not, right? uh, yeah, this DP form is easy and most common form of DP. Mostly you can wherever you think of a DP solution, you can think that uh, this can be the case. Okay, so let's see the transition types. So let's say we are having a DP state like DP of level comma x, which is storing the best result in interval level to last index of that array, such that x is something which I have already taken care of in that interval 0 to L minus 1 or level minus 1. So we have to make two decisions, right? We can take this level or we can't take. Let's say if we are not taking this level, that means there will not be any change in this x, right? But the value will be equivalent to the DP state of DP of level plus 1 comma x, because I haven't taken this current state, right? But if I am taking this current state, this will contribute in my answer, right? So this will contribute something, and the DP state and the second contribution will come from the next DP state, which will be DP of level plus 1 plus comma. Obviously I have taken this current state inside my uh, I have considered this current state. That's why this previously taken variable x will change to new variable, right? And based on the problem statement, we can do some kind of operation on these DP transitions. Let's say we can add these to find this DP of level comma x, or we can take OR of this, or we can take minimum or maximum out of these depending upon the question. That's how in general form 1 DP transition looks like, right? So this is all about form 1. So let's quickly go to the form 2 where yeah, form 2, or you can say the ending at DP. This is also an easy and common form of DP. In this kind of a DP, in general, we formulate DP state something like this: DP of level comma some constraints, or you can say some variable, which are storing best result ending at this index or starting at this index. Here we are not here we are not taking decision whether to take this level or not. Here we have already decided that we have taken this we have already taken this level into consideration, right? That's how this DP state works. So the best result, that is ending or starting at this level, such that these x1, x2, and so on are already are some decisions that we have make on state level. I guess this seems to be something confusing to all of you, but trust me that this state will also become easy to implement for you whenever you when we will discuss some problems on that. This is also a DP form. In general, this type of DP form is used when at each level we try to find best result ending at that level, right? And the transition to this type of a DP state looks like something. Let's say DP of level comma something, which will be equal to. Basically, I'm trying to evaluate this state using some previous DP state based on some conditions, right? So DP of level comma something will be equals to some contribution plus DP of previous states, something like this. The transition of this DP, this form will look something like this, and we try to calculate the current state using some previous state that I have already discussed. And the problem types in which we use this type of a DP state are generally subarray problems or substring problems, and sometimes in subsequence problems also. Okay, so let's quickly go to the form 3 DP. This is very, you can say, specific type of a DP form. You can easily identify where to use this type of DP form. This is a multi-sequence DP, right? So in general, we use this type of DP form wherever we are having multiple sequences or multiple arrays or something like this. Let's say if I am having string S and string T, and we have to uh, like find something, let's say minimum cost to match these strings or something like this. So in general, we form DP state in this type of problems like this: DP of I comma j, some which is storing the best result I can have while considering substring of s starting at ith index and substring of t starting at jth index. Right. This That's how we formulate the DP state in this type of form. And let's quickly see the transition. In general, the transition of this form looks like something like this, where we can we can skip the ith index, which will cost me something, and we can skip the jth index, which will cost me something, and if there holds some condition, we can skip both I and j, and which will give me some cost 3, right? This will become crystal clear when we will be coding some questions based on these forms. That this is just overview of all the DP forms, right? So don't be confused. And based on the problem condition, given problem, we can take max or main or add or take bitwise or of all these transition. So that's how form 3 looks like. Let's quickly go to the form 4 and form 5. Okay, so before proceeding to form 4 and form 5, let me tell you that form 4 is a tough kind of a form. Basically, it's an interval DP. Uh, in general, you will face this type of DP in hard problems only. Let's say if you are doing lead code contest, you can see this kind of DP uh, mostly in fourth problem. Okay, so this is an interval DP where we form DP state like this: DP of L to R, which stores best result that I can have while considering interval of this array from L to R, right? So transition for this type of DP state is basically we try to break this partition. Let's say we are having this interval, right? L to R. We try to break this interval in two intervals about P. So the two intervals will look like L to P and then P plus 1 to R, right? So, in general, the transition for this type of DP states looks like something this. For check for some partition P's based on some conditions. So DP of L comma R will be equals to some cost plus DP of L to P plus DP of P plus 1 to R. Because these were, in general, these are the pre-solved DP states, and we can evaluate this DPL to R based on these values: DPL to P and then DPP plus 1 to R. That's how DP works. And the form 5 DP is a game DP, and I will discuss this with problem only. So these are the 5 DP forms, or you can say frameworks. I can tell you that mostly like 80 to 90% DP problems you can solve by using at least one of these DP forms, right? So let's quickly summarize all these DP forms. So yeah, this was the first DP form in which we take or non-take that DP state. This type of DP form we use in general wherever there is a case that at each level we have to make decision whether to take this level or not. In that those kind of problems we use this DP state. And form 2, right? So form 2 we use in those type of DP problems where there is involvement of subarrays or substrings, or you can say subsequence also. And the DP state in general looks like this: DP of level, which is storing some best result ending at this index level. Okay. Okay, so yeah. And form 3. Form 3 is multi-sequence DP. You can see think that this form 3 is kind of a combination of form 1 on two different sequences. And form 4 and form 5 I will discuss with problems. Let's quickly go to the part, basically the general method to solve any DP problems. So to solve any DP problem, I generally follow 5 steps. So let's quickly go through all these steps. First step is identify the DP form. Then after identifying the DP form, you can easily define the DP state. After defining the DP state, think for a transition, which I have already discussed for each DP forms. After uh, thinking about transitions, check for time and space complexities of that particular algorithm and check whether this is favorable for our problem or not. There is a formula that exists for DP problems to calculate the time complexity. So the time complexity for DP problem is big of number of states times 1 plus number of transition, and you can easily calculate the number of states and transition based on the uh, transition and state which we have already uh, evaluated. And after that, if there is a green flag for next step, go and code the solution. Okay, that's how in general we tackle the DP problems. That's all about the theory part. In next video, I will be discussing new and for that, you can revise this. Bye bye.